Thank you everybody for coming out. It's a nice day outside. Summer is officially here, or else almost here. And so I appreciate that everybody could make it. I'm going to see if we can move on here. So I'm going to just make a little bit of a clarification. I'm going to talk about homes, but this could also be applied to buildings as well. So, you know, homes is just residential complexes where a few people live, but I also want to, a lot of this applies to buildings. So just keep that in the back of your mind. So let's go really big picture here. What am I here to talk about? There are two big balloons that are sort of changing the world in this energy area. One of them is, of course, there's digital home technologies. All these little devices in your home that used to be dumb, but are getting smart. I mean, it's all sorts of things. I mean, from your TVs to your appliances to your HVAC systems to whatever. Every little item is becoming smarter and smarter. On the other side, there's another balloon that's happening, and then I'm sure that now that we live in BC, we're always hearing about BC Hydro's smart grid project. There's all sorts of smart meters going in. There's alternative energy programs. But these two balloons are side by side, not necessarily intersecting right now, but within a year, few years, 5 years, there's going to be a direct intersection, and I'm here to talk about that intersection. That is why I'm here today. And that intersection is commonly known as the home area network. So just as a background on me, thank you for the introduction, but so my background is largely based on things that are controlled through electronics, and you need software for that, you need chips for that. So that's my background. So I've been able to apply this in this area, and my company, Embedded Automation, focuses on these kind of things for sensors and things we can control electronically through software, and we have products that do that. And lately we've got into energy and energy monitoring solutions. So we're going to talk a little, this becomes into the discussion here. So some of the projects that we've worked on that are relevant to this discussion today, about 3 years ago, we were involved in a very innovative sort of project. It's called a solar decathlon. We were involved in helping build energy efficient homes, and they actually have a decathlon to see who can build the most energy efficient homes. They have this down in Washington. We were in 2 homes, and we came in 4th and 7th place. And that kind of work led to a project here by SFU called the West House, which was showcased during the Olympics and is now actually in Stainsbury Street and in Vancouver. And you can actually, it's a living lab. It's a house that they monitor, and they're collecting data on it. People are living there, and they're trying to figure out how they can sort of save energy and how they can display energy usage to the people that are living there. One of the other projects we're working on is actually a building automation or building energy monitoring solution. So we have a partner that is actually monitoring buildings, entire buildings, and displaying that information out to people. So I'm going to start out by talking a little bit about the history, the present, and the future of the 2 balloons. So the first balloon I'd like to talk about is the digital home technology balloon. So we're going to leave the energy stuff for the side for right now. We're just going to talk about the history of the digital home. So I don't know if you remember my old school, you probably remember thermostats that looked like that manual thermostat there. They were totally dumb. And what happened, probably around the 90s, they came out with these programmable thermostats. So instead of just one setting, there was multiple settings based on the day of the week and like the time in the day. So that was a big step up. Then what happened is people said, now that we have this smart thermostat, we can start building communications to it, so we can talk to it. Wouldn't it be nice that we could actually send messages to it and have it change while we're, let's say, outside the house? We could send by remote control a message to heat up our house or cool our house. Well, that's actually even gone a little bit further. I don't know if you've ever seen the new thermostat, which actually looks like the old thermostat. It's called a Nest thermostat. It's actually sold by Apple. Guys from Apple actually designed it. and it actually starts being intelligent. It starts remembering what settings you have, who's in the house, and it actually communicates, and it works with your iPhone. So now it's actually taking on not just communicating, but actual intelligence. But this has happened throughout the house. I mean, it's happened for security cameras, which are now IP pluggable. They can just, you plug them into your regular Ethernet network. They're cheap. You can buy them at Best Buy. It's happened for lighting systems. These lighting systems are, instead of, if you want to take out your switch and put your dumb switch and put in a new switch, now you can talk to it and control that switch, and you can control your lighting in your house or your building. It's happened for security systems. Security systems are now fully controllable. You can get a SMS message or text message on your phone if there's something happening on your security systems. There's people selling programs where you can actually go in and view exactly what your house situation is. That's a program that's available. Your audiovisual stuff. If you look at the brand new TVs or AV devices, they have an IP port, or they have like a serial port, and you can talk to them, you can command them. And so all of these things are controllable, and they've got more and more intelligent. And there's going to be more devices. So there's going to be appliances. There's an organization called CABA, Continental Buildings Association. What they do is they're actually doing pilot projects on smart appliances, how these appliances could talk to your electrical system. Medical equipment. My dad's got a USB monitor. We test for glucose. He can record those onto his computer. And of course, there's going to be electric cars. That's going to be a big change, and that's going to come into our digital home as well. So for these devices to actually become communicating, they have to have what we call protocols, or a communication capability. And there's been, in the last 15 years, 10 to 15 years, there's been no less than 20 that I can name off in my hands, just of new protocols. In fact, it's so many, I can't even keep up. I mean, I work in this industry, and I literally cannot keep up with some of the new innovations that are happening here. I mean, I've listed, I think, about 10 or 15 protocols, but there's another 10 or 15 that I could have listed that are probably not as prominent. But I'm just going to go over the couple of them because we're going to see these over again, okay? So the top one, Zigbee, you'll probably hear that word a lot. And one of the reasons you'll probably hear that word is inside every BC Hydro smart meter, there's a Zigbee chip. And that Zigbee chip is going to allow talking to something. So that will set the stage for later on in the conversation here. But it's wireless, but it has a potential to also talk over power line. I'm just going to explain what power line is that your electrical system, the wires that are in your home, they can not only be used to send power to your devices, but we can actually communicate on them. We can put another signal on there and use those wires to exchange messages. And that's what power line technology is. Insteon is a large protocol that's being sold in the States, and it probably has the most number of nodes installed. So despite, maybe it doesn't have the prominence of Zigbee, it actually has the most nodes that are being talked to. And then there's some other protocols, some more relevant in Europe than in North America, some more relevant to the entertainment industry or media devices like TVs and streamers, and some more relevant to buildings. But I just wanted to create this slide for you, and then I'm going to make this slide deck public, so if you ever want to come back to this slide, you'll have this for reference. So one of the reasons we started embedded automation, we got into the digital home space, is because we noticed that there was actually a change that happened. One of the big changes that happened was in about 2005, in addition to all these smart devices, in addition to all the protocols, there were finally some sort of common user interfaces, right? So before, when you had a digital home, you didn't really know how to talk to your devices. You'd have to go to your thermostat, it had one user interface. You'd have to go to your washing machine, it had another user interface. You had to go to your lighting system, there's no user interfaces. But for the first time in like 2005, there was like some standard user interfaces being developed, graphical user interfaces. Now, there was always graphical user interfaces available for industrial applications, but not necessarily for home applications. You know, probably the most prominent user interface that everyone has, you know, is their smartphone. So this is a really recent thing. So now you can actually have your home in your pocket. So where we got started is we saw it first in sort of like the TV interfaces. So you have like our product M-Control 2, it's actually talking through an Xbox and you can see what's happening inside your home. But that could easily be applied to Apple TV. And on the top right hand, I have, that's a picture of Samsung TV, Smart TV. I don't know if anybody's ever seen it before, but you can write apps for that and those apps can be talking to your digital home. And then of course, this is a proprietary touchscreen. These things are like $199 that could talk to your digital home. But probably the most prominent and most important user interfaces are things like your mobile devices. So what happened? How come we haven't got all these, you know, Jetson type of stuff like George Jetson homes that, you know, like controllable thermostats and lighting and all this whiz-bang stuff? Well, I put it down to the 3 C's, right? Number one is cost, right? So if you wanted to take out your dumb light control and put in a smart light control, you know, you're going to pay a premium. And that premium is just way too high right now. Nobody's going to really do it. It's only the early adopters and the real technical geeks, you know, that are going to really get into this. The other thing is it's still too complicated. It's still, you know, this is just a screen that I picked up randomly out of like a device that you might want to set up so you could actually control it using your mobile phone. That's way too complicated. There's, you know, like if my mom can't program or use the digital home, it's never going to work. So this is something that just is not something that we can actually make available to consumers. And another big thing is the chasm. And hasn't been one sort of or multiple technologies that have really taken off. And that really would help a lot to reduce costs and complexity, right? Because if we had Zigbee chips that took off and it became the predominant sort of protocol, then, you know, people would build those chips in mass and we'd actually reduce the cost of the devices that we put in. And then actually, there'd be a standard way of doing things, so we reduce the complexity as well. So those 3 things have really prevented the digital home from really taking place. So, and there's obviously another big thing. One of the big things is, I love this blog. This is calculatedrisk.com. This guy does, he removes all the politics and all the stuff, but he does presents data on the economy. This is one of his famous charts. I'm going to give you quite a bit of chart porn today. But here he's showing how new home sales in the US are at generational lows. So a lot of the digital home business was based on applying new technologies to new home buildings. But you know, if they're way, way down, there's less of a market, there's less of a demand. And so this kind of, the digital home industry has kind of come to somewhat of a stop. There's things that are happening, but this has really affected us. The other thing is that even existing homes, they're being sold by banks. Banks are reselling them, or they're short selling. People are selling them just to get rid of their homes to get disposable income. And so people aren't investing in sort of bringing their homes to the modern level, so that they're not really interested in building the digital home. So there's a lot of other macroeconomic factors like disposable income, but this is probably a big sort of like reason why the digital home hasn't really taken place. It was actually doing very, very well, and then the interest has subsided a bit. But there are some things that are really changing, and now we're going to talk a little bit about that. And one of the things that is really changing is the second bubble that we're going to talk about, which is the energy delivery system. So this has gained a lot of prominence, and what the purpose of this energy delivery system, I'm not going to talk, I'm not from BC Hydro, so I'm not an expert on that, but I want to just talk about at high level what these energy delivery things are going on and how it impacts into the digital home. So, big picture. Let's go to the highest level. I love this picture because sometimes you can't really figure out what's going on in energy use. And there was this wonderful slide that I found about a year ago. And if you look at it, this is how energy is used in the US. So this presents a really good summary slide of like how energy is being used and where we can make a difference, right? So well, I'm specifically talking about the residential area, but some of it also can apply to the commercial. And there's a ton of energy being used. So one of the things that now you see this slide and you can understand that BC Hydro's goal, and actually most utilities and most governmental goals, are to require conservation. So if we can actually start saving some energy based on that enormous use, it's going to be of great benefit to society. There's another reason for conservation. Because of government situation, macroeconomic environment, you can't go out and build a power plant. You don't have the debt financing to go do it. There's environmental issues. So conservation makes not only sense to save energy, but it's something that the only thing you can do. So there's great programs already in place for working with conservation. BC Hydro, has a Power Smart program, and actually I was talking to Dave. Dave, where did my LED light go? Oh, here it is. There's, obviously LED lighting is coming along, and so it's good to see, the BC Hydro is promoting all sorts of conservation programs. There's a great program by the Government of Canada that you can make your home more energy efficient. And obviously there's like appliances. You can choose the right appliances to buy. Actually, this leads to a point that I think it was about 3 GreenTech seminars ago. There was a great speaker here who was a building expert. And he said one thing that I took away that was really important. He said that it's important to get your base low-tech solutions in place first, then worry about the technology. And I happen to agree with that, because if you get your base technology, you get a house with good insulation, good windows, good lighting systems in place, you're 80% of the way there. Using technology to solve these is more of a tweaking exercise to get the extra little bit of stuff, but the base system, we have to rely on these kind of programs. So I just wanted to share with you some success stories, and I know this chart's a little small. I'm going to show it to you a little bit bigger, but I see these kind of stories all the time. And there was a wonderful little article last week, in fact, on June 22nd, about a guy who cut his energy bill by 2/3, so much so that the state decided to audit him. And it was, they thought he was running a scam because he was able to do, and he used it. And I want to state, by using no technology, he just did standard, basic. He improved his insulation, changed to LED light bulbs, changed the furnace. Started reducing, used programmable thermostats, and he was able to reduce his energy use substantially. So, to the chart porn. So this is like a list of things that you could do. And again, these are all basic, low-tech, no technology things. For example, the number one thing there is freezers, changing out freezers. So these are the biggest impact things that you can do to improve our energy use. None of this is, and by the way, like I said, I'll give this to slide deck, and you can find where this link is, and you can get this chart. So we haven't even applied technology yet. So what happened about 5 years ago is that a couple of our colleagues, partners in the industry said, okay, we've done the base stuff. Well, what if we started using technology now inside the home and can we make any incremental improvements? So one of the first guys that we worked with was a guy by the name of Michael Breton. He was actually, Intel formed a group called the Digital Home Group. So what they basically, their mission was to, integrate these devices in the home. Basically integrate energy and all these disparate protocols together. And his project was to hook up a smart meter to his HVAC system and other devices. And so that's what he did. And sure enough, he found that he was able to save money. His trick was, he knew it was going to be, he'd look up his computer would look up sort of the weather forecast for the next day and pre-cool the house instead of having the thermostat, adjust the thermostat, and he was able to save money. So basically this home was starting to make some smart decisions. Now, it's just the first step. It's not a commercial product, but it was the first project that we saw and where we participated in somewhat that, fed this back. And again, he was putting this on a user interface through his TV, through a media center. So very, very interesting project 7 years ago. Then what happened is these ideas kind of started going forward, and you started getting new products, actual products that are consumers could purchase. Probably the most famous one, I gotta love the name, TED 5000, the energy detective, no relation. It was a product, when it was first introduced in 2008, for 2 years they couldn't keep up with the backlog because people were buying this, hooking it in their homes, and finally seeing real time what their energy use was. Because before you couldn't do it. There was guys that are obviously tinkerers that were doing it, but this was a consumer device that was available. And this was shortly followed by a British company called Current Cost, the Envy. And once they got those products working, Google jumped on board and said, you know what? You're collecting that data. Why don't you send it to the cloud? And we'll have a repository for you. And then you can do historical analysis. And sure enough, Google's Google Power Meter was born. Microsoft decided to copy them and created a place called Microsoft Home. These two, I'll see if I get this pointer working. These two items now are defunct. They're closed by the things. But it's good to see that Google still is very interested in this space. And they've created their own protocol called Google at Home, which is now wants to talk to all these type of devices. And we introduced our own little energy monitoring things. So instead of just monitoring your whole home, we started selling solutions that you could monitor actual individual loads. So you didn't have to monitor your whole house, you could monitor how your fridge was working. And that fed right into a computer that you could see real-time display. Okay, so you had these consumer things going on, but then the utilities, started talking about the smart grid. And again, I don't want to talk too much about the smart grid. This is really outside my area of expertise, but I just want to give you the big picture. So the big picture here is before, I'll just give it to you in a very simple way. Before, you had a dumb meter outside your house. It was basically, it was an analog meter that just gave you a value, and some guy had to collect the data every once in a while. But what if we could do the same thing that we did for thermostats? What if we could actually make it talk? And that's exactly what happened. So basically now we're replacing the meters that are outside your house, and they now talk through the collection to another base station and eventually to a data control center. And so now you can have all these meters feeding in, and BC Hydro can have a real-time usage information. They had this kind of information only going out, but now they can have a feedback and say, oh, this is how it's working. This house is actually, this neighborhood is down. Actually, there's a company called BitStew here in town, really doing some innovative stuff. They actually have put all of BC Hydro's meters on a Google map. So you can actually, on Google Map, you can see every meter BC Hydro has. And they're selling this solution to other locations. So now we have real-time information going back and going this way. So it's bi-directional. So from my sort of perspective, well, BC Hydro sees it differently. From my perspective, this is a giant information network. This is a network that's going to communicate with my home. So why would we spend all that money to build a smart grid? Well, I mean, you could actually, if you just Google, this is one of like 50 charts that'll come up that tell you that, you know, even if we get a 3% saving through smart meter feedback, look at the crazy numbers you save in terms of like payback. So it's like any network. Once you build it out, you have that information, you have so much capability to improve your utilization. And so this is just one area of how the smart grid is going to help. I mean, it doesn't affect the digital home, but this is just out for BC Hydro. They can justify building the smart grid. Sorry, there's some static there. Okay, so now I'm going to get closer to our perspective. There's a poll that was done by Harris Polls, and it's almost common sense. I mean, if you knew how much energy you were using in real time, would you do something about it? Yeah, probably. You know, like, I mean, about the only time you look at right now is the only time you look at your energy is like when you get your bill, right? And I love asking the question, how many people know how much cents per kilowatt hours do you pay? Maybe 2 or 3 people. I would say that when I do that in a general audience, 98% of the people don't know their rate. They don't know how much energy they consume in a day. They don't know how much their fridge is using. They don't know how much their living room is using. So the first step to solving a problem is to know something about it. So, I mean, this is all common sense. If you could have that information, you'd be able to do something about it. And the benefits, of course, are, again, equally obvious. You know, you're going to conserve energy. Things are going to get more efficient. And and another side benefit, which is huge, is reliability. You're going to have instant information. I mean, it may surprise you, but BC Hydro didn't have that real-time information. So if a neighborhood went down, they didn't necessarily know that neighborhood went down. Now they actually get alerts. They get, you know, their operators get text messages directly on their phone within like seconds of a neighborhood going down. They didn't have that before. Okay, so now we're getting closer to the home. And I want to talk about networks. So first of all, smart meter, it's got a network, but actually it's got 2 networks, right? So it's got the network that actually talks to the utility. I call it the Utility Information Network. BC Hydro may have another name. And then there's another network, which I'm calling the Home Area Network, which talks into the home. Okay, and there's a wall right there. That's your house's wall. Your smart meter is outside. It's important to know that it's outside because BC Hydro doesn't necessarily want to, can't come inside. I mean, there's all sorts of rules on what they can place inside. And I've drawn, those are not earrings, by the way, those are locks. So these are secure networks. And so what kind of, over the Utility Information Network, they can send us pricing info. They can pull information on how the meter is doing. They can send messages to the user. And every, you know, N hours, 4 hours, 8 hours, they can't do it real time because it would just clog up the utility area network, but they can get information about that meter. The home area network is another network that ties into the home, and it can give you pricing information, messages to the user, and it gives you near real-time energy information. So this network is a protocol determined by the meter manufacturer. So in the case of BC Hydro, they use a meter made by a company called Itron. Itron has their own protocol for talking to their base stations. So this is that network. The home area network is another network. So basically, if you want to think of it, there's 2 chips. One chip talking this protocol, one chip talking that protocol. In the middle is like a CPU. The smart meter has a CPU that's, you know, can talk to both networks. Now this protocol, interestingly enough, is somewhat consolidating on one type or 1 or 2 standards. And predominantly, that standard is Zigbee. If you remember me from about my 4th slide, I mentioned the Zigbee protocol. So, and in fact, what Zigbee did, the Zigbee Association, what they did is they actually tailored one of their protocols and called it the Smart Energy Protocol. And that protocol is especially made for meters and for the home area network. So let's talk a little bit, look inside the home area network now. So for BC Hydro and the like, they'll probably just want to, they consider it like this. There's a smart energy network, and it's going to be a smart meter, maybe talking to appliances, maybe talking to some sort of displays, maybe talking to a thermostat or other things. But from our perspective, because we have visibility of the digital home, there's a whole bunch of other devices. Now, it could be the case, we believe, that all of these devices will be linked in the future. But so we, Embedded Automation, define the home area network as all of this, right? But BC Hydro and energy companies will often just limit the discussion to this. But so ours covers the whole digital home, theirs covers just sort of like the things that the meter will talk to. Okay, so what's happening? What's the state of the home area network now? Well, it's crazy numbers of meters that are being installed worldwide. And most of these meters have hand capabilities. That means that they have 2 radios, one that can talk out, one that can talk in. And I mean, we're looking at maybe, remember I was talking about the issue with the chasm? There hasn't been a single standard. We are hopeful at Embedded Automation that this is going to help cross the chasm. This is going to help us get to some sort of standards that are going to be applied not only to smart meters, but all through the digital home. So let's talk a little bit about Zigbee Smart Energy. So this is the predominant protocol for hand communications to date. It looks like it's going to be the eventual winner. Who knows, maybe something will come along, maybe Google at home will take over. But there's a lot of Zigbee chips being built into a lot of smart meters. And I'm going to lead a little bit technical here, and I know Chris is probably going to slap me around and just say, don't be too technical. But so the way that it works right now is, Chris works at our company, so he's a Zigbee expert. The smart meter is really the master. So as for when it sets up its Zigbee network, it's the master of the network, or the term that they use is coordinator. And all the other little things inside your smart home are actually called nodes. Right now, the standard for Zigbee is version 1.1, and it's going to go to 2.0. That's part of the reason why your smart meters that are being installed at BC Hydro really don't have their hand network turned on. So, yeah, maybe I'll just go back to that. I'll make that point. It's an important point. So, currently for BC Hydro, this network is turned off. It's installed with only this network working. Sometime later, probably the end of this year, early next year, they're going to turn this on. Okay, they haven't turned this on yet, and because there's no reason to. Part of the reason they haven't turned it on is they need to resolve all these issues. Like the standard is still moving, it's changing, and so they're going to have to do some issues. They're going to have to update the firmware. They're going to have to do this, figure out how to update the firmware. They've got a plan to update the firmware, as all smart meter installers are doing, but it's still an issue that they have to deal with. So BC Hydro is very, very supportive of the Zigbee Smart Energy profile. So much so that they took their pricing mechanism, which is called, and this is again arcane sort of stuff, it's called residential incline block. That means is if you use this, after you use this much energy, they're going to charge you at a higher rate, and so it's inclining a block. So they call it residential incline block. They've actually taken this to the Zigbee Association and built this into the standard. So one of the reasons why this the smart meter thing hasn't turned on, they're waiting for the RIB solution to be implemented as part of the thing. And also, BC Hydro, about 6 months ago, launched a notice of interest to HAN vendors. Basically, anybody that's selling devices that will talk to Zigbee, you want to participate in our HAN environment. So BC Hydro is really going to be pushing the ecosystem, HAN ecosystem. This is something that's going to happen over the next 6 months to a year. Okay, so now we've seen kind of like the digital home network. We've seen a little bit of the HAN. I thought I'd throw a more detailed kind of future-looking diagram of what the home might look like in the future. So obviously we've seen the smart meter. We've seen that there's a thermostat that might talk to it. What if that thermostat, if in California, for example, they're talking about, if we have plenty of energy here. In California, they have issues with how much they can generate, the capacity that they can generate. And when it's a really hot day and everybody turns on their air conditioners, they may have issues delivering all that energy. Wouldn't it be great if they could send out a message over their smart grid, over the HAN, to your thermostat to say, do something about it? So that way they can be assured that there's going to be no lack, there's always going to be capacity. So that's one of the reasons why they're looking at things like smart thermostats, because it's a way to measure or a way to manage demand. One of the things that we'll see, and we'll probably see here in the next 6 months to a year, is things called in-home displays. And these will be little devices that sit on your countertop that talk directly to your smart meter and give you real-time information about how much your energy. It's very much like the TED 5000 I was talking about, but instead of talking to like some plugs in the wall, it's now going to be talking directly to your smart meter. So this is something that we'll see. In fact, I'm going to show you in the next slide. But we're also probably going to be able to get other information from BC Hydro's website. So BC Hydro will have, has collected data at their data center, and now is consolidated, put it in your account, and you're going to be able to log into your account and see, what kind of information about your meter. There's going to be smart appliances, and a big thing that we have to prepare for is electrical vehicles, because they're going to demand a lot of energy use, and we need a way to manage it. And fortunately, the smart meter is going to be able to send us messages or send messages and talk to it and help us manage the power use. I thought I'd throw this slide in because it's kind of interesting to see how much stuff is happening locally. There's 3 companies that I can mention locally that are working on real-time displays and a lot of other things. But there's a company called Energy Aware that, they're very involved in the GreenTech community, that they've built a thing called a Power Tab that gives you a real-time display of energy. There's a company called Rainforest Automation. They've got their own display, and they're selling this worldwide. And of course, we have mechanisms to show it on things like an iPad. But that's all happening locally. So I'm just now kind of just looking at the opportunities and threats of what does this kind of mean? Well, the biggest opportunity I think that we have is the whole idea of customer or consumer engagement. If you know this information, if you can build your house to take advantage of this information, I think this is going to be a real benefit to society. I mean, you're going cost savings, etc. I see this being built into, I see the Zigbee chip going down dramatically in cost, and the technology getting easier to use and being embedded in everything, including appliances. I think that there's going to be things like demand management that's going to happen automatically. It's, there's going to obviously have to be some setup and things, but I see this happening over time. The same technology, local power generation. One of the things the smart meters can do is they can recognize how much energy you're taking in, but potentially how much energy you're creating through solar panels and pumping back onto the grid and give you a net sort of value. So that's another thing that smart meters can do. This whole technology currently is I'm talking about and being applied to electrical meters. There's no reason why this same sort of concepts can't be applied to water and gas meters. The other thing that we see is like being integrated into your regular IP network, which is and now you have the whole power of the internet coming to you. So there's a lot of opportunity there. I drew this because I think there's going to be a Zigbee chip in there someday. So some of the hand limitations, I mean, it's not all, there are some downsides. One of the things is that we see is like, or talked about, and I know there's strategies to solve these problems. So people have recognized these limitations already, and they're trying to solve them. So one of the things is like, if you got a smart meter installed outside your house, but your hand connection is far away, maybe there's going to be no connection. What happens then? And this is really important for multi-unit buildings, like let's say condo complexes. Like if you have in the basement of like your apartment, you have all the smart meters. How do you reach that information on the 19th floor? So that's an issue that we're going to have to overcome. Smart meters give you sort of a composite view. They give you like a total view of your energy usage, but they don't really tell you how a room is functioning. They don't tell you, your home theater room is sucking all the energy. Maybe you want to clean up that room, throw away your old DVR and get a new DVR that uses half the energy. So that it really gives you a composite, and it'd be nice to also have a load-based view. So taking these into account, I want to give you kind of a vision of what I think is going to happen and this is kind of a thing that we've been working on at our company. And for all you guys, this is the last slide, so it's exciting. So what we see happening is that in addition to the smart meter, you're going to have individual loads, and on this side I didn't draw it because we're not really talking about security systems or other things. But we believe, and we're working on this, is you can have and this is maybe perhaps more relevant for buildings than it is for homes, but we believe that there's going to be solutions for the consumer and for businesses that's going to allow people unprecedented information about energy usage. And if I was to end on one note, this is kind of like the summary of where things could be going, is you'll be able to get this information, and not only get this information, use it to trigger other decisions automatically. So anyways, thank you very much. I hope that was educational. Any questions from anybody?
So those devices, how much are they typically cost?
Which devices?
The measurement devices.
For the load?
Yeah, the two you described, the two measurement devices, how much they cost?
Oh, for measuring just electrical usage for like a room or something like that? Currently they cost about $75, which is, I mean, you couldn't even get this stuff like 3 years ago, and it would cost like $250. But I would say that you can buy it off our website, right? These things are now consumer grade, but we see that coming down in price over time. And it really comes down to like, as these things get more and more installed, I mean, where could it go? Could go to $10. I mean, it'd be great. That'd be a great vision for where it should go. So, thanks. Go ahead.
Could you talk about the role of utilities in underwriting the expense of these devices?
So it varies from. So the question is how are utilities sort of like paying or helping build out this ecosystem? Right? Is that the question?
Underwriting the devices.
Okay. It depends from utility to utility. Right? Some utilities are basically giving you. And for example, this is a good question because in some utilities that are, there's government utilities, there's public utilities, there's private utilities, but some private utilities that are in unregulated environments, they want to capture your business. As part of the capturing your business, they will give you a device that allows you to monitor this stuff for free. So it's like a toaster when you open a bank account, right? Same sort of concept. So some utilities are doing those kind of things, right? Some utilities are building ecosystems by not necessarily paying for the devices themselves, but helping you market them. And I think that's more of a role that BC Hydro might take. They may not pay for the actual devices, but they'll help you kind of promote under the maybe their kind of BC Hydro brand that these are recognized products that would work. So it varies from utility to utility, but I think that there are going to be some utilities are going to participate. How they exactly participate to help build up the ecosystem depends. Does that answer your question?
It does. It might also be worth pointing out that some utilities are investing in this infrastructure because it's less expensive to do so than to build up new power generation.
Yes. So, I mean, the whole idea of conservation, right? So if we can get the consumers knowledgeable on their energy use and get them to reduce energy and build devices that can respond to demand messages, we're not going to, hopefully we're going to conserve the amount of energy, therefore we don't have to build power plants. And yes, so there is incentive for the utilities to participate. Good point. Yes. Question back there?
What is the maximum range for the smart energy before losing the connectivity with all the units within the house?
Well, one of the interesting things is, first of all, it's a mesh network. That means that one device can talk to another device, it can talk to another device, they can talk through each other. I think the technical specification, correct me if I'm wrong, Chris, is 30 meters? Well, it can range up to about 400 feet. And it depends on line of sight versus obstructions, but I think that Zigbee accounts for being able to reach inside the home. So, I think the specification is 400 feet. No, 400 feet from one node, from the master to node. Yes, question back there?
Not all smart meters are wireless. A lot of provinces, states, have wired ones, even telephone network. How does that affect some of the ideas that you discussed?
Again, two different networks, right? So there's a backhaul network or the utility network, which is, they're using different, not necessarily, you're right, not necessarily wired. They might use even a power line back to their base stations and then on to the data center. But for most home area networks, we're looking at wireless. And then there's a technology called Home Plug, which is providing an alternative to the wireless, which is over power line. But predominantly speaking, the vast sort of like the environment we see, the home area network, which we're talking about, is wireless. Any questions?
Once this hand thing gets turned on, all these people making the energy monitoring devices will go out of business, right? Because it'll tell you the same information, and all you need is a thing that can read it.
Yeah, so you mean like the TED devices and the Envy devices? I think that they have their strategies to start talking to so I know that they've got projects that they're working on to instead of talking directly to your power panel, they're going to also switch to using the Zigbee protocol. So you're right. I mean, the way of the future is talking directly to the smart meter.
I must say I have a slight problem with the idea of working around the smart meter as the centre for. I think we should be moving away from that, and we should have our own. There's plenty of technology and plenty of protocols out there, and electricity only makes up a very, we get most of our energy goes to space heating and domestic hot water. So electricity is a very relatively small factor.
Yeah.
My point is, we need to have, to have everything driven through the smart meter. I think it's problematic.
Yeah. So I mean, I think that the general consensus is that within heating and cooling of your house is 50% of the energy. Yeah, it depends on the region, but yeah, I agree. Your point is valid. And so what I mean, this is a very narrow topic, right? And we're talking about electrical conservation and how it applies. But you're right that there is really, there's, the whole idea of, bringing gas and water into the equation is really an important overall big picture. And so we should have this information anyways. I mean, it's great that we have the smart meters. It's just kind of like a device that's going to give us this information, but I understand your point.
Yeah, no, and I think it's great that you guys are bringing this technology and to bring it forward and offer it. It'd be great if we could kind of bring sort of people from multiple sources together, wouldn't it?
Right. So, yeah, I think one of the struggles has been, like I said, there's such a plethora of protocols that it'd be nice to start to consolidate, and I think it's starting. Yeah.
Cool.
Question here?
Is there a significant downside to just using power line besides?
Well, yeah, the downsides of power line, first of all, it has been that, one branch of your home there might be an interruption to another branch in the home. So a device that's talking, so we're talking about power line sending messages across your electrical wire inside your home. The traditional problems has been that there might be interruptions in between. So one device on this side of your house may not be able to, because of noise or other issues, may not be able to talk to a device. But Instient, actually, one of the protocols that I discussed, has actually done a pretty good job. It's pretty, and there's even another protocol called UPB, another power line. That's probably the most robust power line protocol out there. But so they made some great improvements. And HomePlug, obviously, with an IP-based thing, this is it's really advanced, but there are some issues. So I really like the idea of having multi sort of like power line and wireless, so you can actually bridge the two. And so and it's good to see that Zigbee and Instient are going that way. So, but there's been great improvements in power line technology. I mean, it used to be terrible, 15 years ago. It's much better now. Does that answer your question? Yeah. Question back there?
I'm struggling to understand that with all these communicating between the devices, we then come to assume that the smart meter can send messages to all the little devices within your home area network, and you have to assume that the little devices know what to do with the messages. What kind of things that the little devices would do if a message received is not using too much energy? So are you saying that the little devices can turn off itself, or it will require a human being to look at it and say what to do with the messages?
That's a great question. That's one of the struggles of is these devices are smart, but they're really not smart enough yet, right? So there is no, it's almost like having a Tower of Babel, there's all these devices talking different languages, and even if they are talking about energy, they may not be talking in exactly the same way. So if you have a power strip that's using the Instient protocol, and you have a smart meter that's talking the Zigbee protocol, first of all, they can't talk to each other. But let's take an example that there's something in between that can translate. Even if you were able to translate, would it be interpreted properly? So these things have to get smarter. The ecosystem has to get smarter. That's why people get, build out start companies to develop these kind of technologies. So it's a work in progress. That's all I can say. It's a huge work in progress, and there's probably been more advancement made in the last 5 years than there was in the previous 25 years. So that's a hopeful thing, and you can see that it's moving in that direction. So yeah, it's still a very disparate network of devices and islands of automation. So we're hoping that these things will eventually come together. Question back there.
Actually, taking your thought just now, to further start, I'm just curious that, what about rather than, just doing, electromechanical smart meter, have anybody looked into maybe like a full PLC or controller, things like that can actually be programmed to, either step down, based on historical data, or is that kind of a overkill at this stage, that?
It really, yeah, that's a good question. I mean, actually, I'll give you a funny thing. One of our previous bosses at our company retired, and he built a home of the future with his retirement money, and he put PLCs in his home, right? So he was, he was kind of like a early adopter of, smart home technology, and he put PLCs. Now, it was a very expensive proposition. So the problems with PLCs are probably those 3 C's that I mentioned: cost, complexity, and chasm. I mean, there's just not a standard way of doing things. So PLCs can easily solve the problem, but it's probably only you that's going to understand them, that you're going to pay the price. What we're talking about is the price to come down from exponentially down to a level where every consumer can adopt it. PLCs, you probably couldn't have every consumer adopt it. So, any other questions?
There are actually alternatives to PLCs.
Yes, absolutely. Again, it comes down to, you can put in, I know that we're working with an SFU PhD student who's really automated his home, and he uses Arduino boards and these sort of like hacker space kind of boards, and really, really low cost. And there's lots of alternatives to PLCs, but what I'm talking about is a real reduction in cost. I mean, making it so inexpensive that the incremental price of going from a regular wall switch to a smart wall switch is like less than pennies or something like that, right? So yes, there are alternatives, but we need to get to a place where this just flows back into the background. You don't even question the cost. You just buy these smart switches from Home Depot instead of like
I think, the General Motors guy said when we produce a car, it's got to be cheap,
yeah,
and then it's got to be green. And
yeah.
I think we need, if we're going to make any progress, then we need to do the same thing.
Yeah.
We need, our systems need to be like, it's a no-brainer to put them in financially.
Yeah. So I mean, I get the message is that there's still a ton of work for us to do, and but there's a vision for it. There's a vision, and it's coming together. The plan is coming together. So, anyways, thank you very much for your time. Thank you.